Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Arifah. Okay, this is the setup of my proposed method. As explained in the slide, this is the subsystem 1. Subsystem 1 is the control circuit that can act as VSI or CSI. So, in this video, this is the setup of VSI. So for the control circuit in VSI, there are 3 sine wave and 1 repeating sequence. Our repeating sequence is the block outputs predict scalar signal that have time values and output values parameters. So for the parameters in the first sine wave is we set the amplitude to M because it is much easier for us to write on the command window. If we want to do the amplitude 0.8 or 1, we just can adjust it at the command window. So we set the frequency is 2 pi times 50 and the first sine wave is 0 radian. Then the second phase is 120 degree. And the third sine wave is negative 120 degree. For the repeating sequence, this is the value that we did. So we put F here because as in M, we can do the 3 condition, which is 1 kHz, 100 kHz and also 200 kHz. So that if we just put the F here, we can adjust it at the command window. Okay, beside the control circuit, there are power circuit here. So let's take a look in one IGBT. In one IGBT consists of the subsystem of the multiplexer and also the 2-bit counter, and also this is a group of 4 IGBTs for each IGBT on conventional method. So let's take a look at here. This is the 2-bit counter gray code and this is the demultiplexer 1 to 4 and the signal here is 4 signal. So let's take a look at 2-bit counter gray code. This is the D flip-flop that we are using for 2-bit counter gray code, and the signal from the 2-bit counter gray code will go into the demultiplexer 1 to 4 and the signal we receive will enter the logic circuit design based on Boolean expression that we have made. Okay, then for the VSI, we have transfer function which is act as low pass filter, is to include the cutoff frequency which we set at 10 kHz, and the scope data 2 is used for the signal before the pass filter. And as we can see here, this is the scope data for after the pass filter, the below this, and the upper is the before the low pass filter, so that we can see the differences. So we use the power GUI as the continuous for this VSI. So let's take a look first. We set at the command window M is equal to 0.8, and the first condition we use the frequency is 1 kHz. So we push the button run. And let's wait. Here, let's see the results of frequency of 1 kHz. We will open the FFT analysis. So let's see, the scope dataset is for the transfer function data, and the input one is the action before the filter. So this is the frequency of 1 kilohertz before it enter the low pass filter, and we can see, we push the button display and we can see the THD is 91.55%. So let's go to input number 2, which is the signal after the low pass filter. So this is the signal after the low pass filter. It reduces a little bit of the signal, and this is the THD of after the low pass filter for 1 kilohertz. We get 84.22%. So next is we do for 100 kilohertz. F is equal to 100 kilohertz. So we push the button run and we wait to get the result. And let's see for the 100 kilohertz. So this is the signal before low pass filter. So we can see that this is high frequency because the shape of the signal is quite arranged tightly. Okay, let's see the THD. Okay, for 100 kilohertz before the low pass filter is 91.54%, and after the low pass filter we can see that the ripples is reduced, and we can see that the signal is much more smoother. And let's see the THD result. We can see there are a big reduction in the THD from 91% to 4.98% for 100 kilohertz. Okay, let's see for 200 kilohertz. So F is equal to 200 kilohertz and run. Okay, let's see for the 200 kilohertz result. Okay, this is the highest frequency, which is 200 kilohertz. This is the result before the low pass filter. The THD is 91.53%, and after the low pass filter is 2.50, which is the biggest reduction in THD. And as we can see, we have achieved the objective, which is to reduce the ripples and also to reduce the THD.